differentiate from first principle, y is equals to x cubed minus 4x. Differentiate from first principle, y is equals to x cubed minus 4x. How do we differentiate from first principle? Y is equals to x cubed minus 4x. So what is the gradient? You must have 2 points, x1, y1 and x2, y. And 1 point must be a beta and x1, y1 will be xy. See just like that. Now let us start. Get what is x1? x1 is? What is y1? What is x2? Remember, for you to move from x1 to x2, how do you get x2? So it is x1 plus the change between them. So x2 is x1 plus change between them, change in x, isn't it? Are we together? So what is x1? Substitute the value of x1. x1 is x. You are writing everything. Oh, y1 is y. We will not put the value of y. So what is y? Go back to the equation relating y and x. Because we are taking all the values in terms of x, isn't it? Y is what? X cubed minus. So you express y1 in terms of x. You are done. Are we together? I am moved. What is y2? Look at the equation. If y is x cubed minus this, meaning y1 is that. So where there is x1, you put x, you get that. Are we together? And if you are looking for y2, meaning everything is true. 2. Are you seeing the scenario? So what is y2? It is x2, x2 cubed minus 4x2. Are we together? Somebody asked Ryan once, just nobody asked. Are we together? You have to look as if we are together so that we move on very fast, even if we are not together, but here we are together, you can see. So, x2 and x2 must be eliminated, everything are in terms of x, isn't it? See, where there is x2, we put the value of x2, meaning we are substituting x2, so what you are substituting, you bracket. Where there is x2, put the value of x2, isn't it? So x2 has been cubed, what is x2? Has been cubed, isn't it? Are we together? Then minus 4x2. What is x2? So everything is start of x, isn't it? So can you now expand this first bracket? How do you expand this first bracket? Hello? How? Binomial. Very simple, isn't it? Very simple. So expand. So when the power is 3, it means how many times? 4. When it is raised to power 3, it means we have 4 times. So 4 times you come and put, that is the first term plus second term. You see, you leave some space for the coefficient, isn't it? Then plus the third term, then plus the last term. So you've expanded this, isn't it? Yes. Then expand this other one. Minus. See, 4 goes inside. 4 times x, 4x, 4 times change in x, 4 change in, see like that. Then put the values, the first term inside this bracket is x, x. The second term here is positive, change in x, so that's just change in x, So, change in x, change in x, change in x, change in x. Then put the coefficients on spot. The first one is 1, the second one is what? Pascal triangle. This is 4 combination 0. You have to calculate. What do you get? There's no room for guess what? Confirm. What are the coefficients? You must learn to work concurrently. You write as you press the calculator. So, one power ascends, one power descends, isn't it? Tuko pamoja? So, the highest power is 3, then 2, then 1, then 0. So that one has descended, meaning this other one ascends, isn't it? So this one is going to start from 0, 1, 2, 3. So you now place everything. You place all the powers and you place all the coefficients, Pascal's triangle. These things are very easy and you are even amused. So here, anything raised to the power 0 is 1. So it means the whole of this is 1 and this one is also 1. So we can simplify the remaining things, isn't it? So x raised to the power 3 is x cubed. X cubed times 1 is x cubed. Then you move here, x is raised to power 2, change in x is raised to power 1. We are simplifying. Tuko pamoja? So we have plus 3, then our x is squared, change in x is power 1. You're done. You simplify that. Move here. X is raised to power 1, change in x is raised to power 2. So you simplify. So we have plus 3 times x times change in x squared. Change in x is squared. So there. Move on, move on, move on, move on. Carry on. Yes, plus change in x cubed. So we've dealt with this bracket. So you can just open the other bracket on spot. You are going to waste time, isn't it? So minus 4. C negative into 4x is minus 4x. Then negative into positive. Are you seeing this bracket? The reason why they need to be there. Because if you don't put them, you mess up the whole thing. Because that bracket means this is the whole term, one term, isn't it? It means the whole of this is, the whole of that is this, isn't it? It's x2. So it must be bracketed to imply one thing. So negative into positive is negative, then 4, change in x. So we found y2. So after finding y2, what do we determine? The gradient, isn't it? We now determine the gradient, which is change in y over change in x. So change in x is just x2 minus x1, you remain with change in x. X2 minus x1, so you simply remain with that thing in the system of change in x. And in the numerator, substitute. Where there is y2, put the value of y2 is x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed minus 4x minus 4 change in x, isn't it? So that is y, then it is minus y. You know, you bracket the whole of it to imply the whole of it is y2. Then it is minus, bracket the whole of y1. What is y1? What is y1?
X cubed minus 4.
Minus 4 change in? Or minus 4x? Good. Then the whole of that is over this in the numerator just doing change in x, isn't it? Then you now cancel. Look at here. Positive x cubed goes with the negative x cubed because negative that. Are we together? Then look at this. Negative into negative is? Are you seeing that? Negative into negative is positive. So it means negative 4x goes with positive 4x. Are we together? Because negative into negative is positive. So this is positive 4x, this is negative 4x. So it cancels out. So what do you remain with in the numerator? 3x squared change in plus 3x change in x squared plus change in x cubed minus 4 change in x. Are we together? Then the whole of that is over change in x. So can you now see? See, change in x is a common factor in the numerator and denominator. Are you seeing that? So you can simplify, meaning you can remove one change in x in the numerator. So if you factorize out change in x in the numerator, here you remain with 3x squared. See there? Are we together? Then plus, here you remain with 3x change in x. You remove one change in x outside. Here you remain with change in x. Then plus square. Then minus 4. We factorize change in x outside, meaning we remove change in x in each. See there? Then the whole of that is over. So change in x cancels out with change in x, isn't it? Are we together there? Change in x cancels out with change in x. So what do we remain with to be the gradient? 3x squared plus 3x change in plus change in x squared minus 4, isn't it? So what do we want? We now want the derivative. So this implies the derivative dy over dx is the limit as change in x tends to 0 of what? Of the gradient, isn't it? Of the gradient which was y2 minus y1 over x2 minus x1, which was what? So limit as change in x tends to 0, which was what? Y2 was f of x plus change in x, then minus f of x, then x2 minus x1 was change in x. Very neat, isn't it? So so the derivative is the limit as change in x tends to 0 of the gradient. And what is the gradient? Y2 is f of x plus change in x, and y1 is f of x. Then over x2 minus x1 is change in. So that is the formula for the first principle. Then you substitute. So limit as change in x tends to 0, the whole of this gradient we found to be what? What have we found it to be? 3x squared plus change in x plus minus 4, isn't it? Then now if we are getting rid of the limit where there is change in x, we put 0, so for us to get rid of the limit where there is change in x, you put 0. So if you put 0, what do you remain with? 3 plus minus 4. So that is what you remain with. Because change in x is 0, so 0 times anything is 0, 0 squared is 0, so 0, 0. So you remain with 3x squared minus